Now, the control word register of 8254 has 8 different fields. The first two fields, so you can see in this picture, the first two fields, that is D7 and D6, you have SC1 and SC2. So depending on the different combination of these two bits, one of the counter will be getting selected out of the three counters. You know, in 8254, three counters are there. Counter 0, counter 1, and counter 2. Each of the counter is of 16 bit, and they do decrement. They do the counting in a decrement process. Okay, they work as a down counter. Okay. Now, if these two values are selected as 0, 0, then counter 0 is getting selected for 0, 1, counter 1, 1, 0, counter 2, and 1, 1. So in case of 8253, this is illegal. 1, 1 is not possible. Illegal. However, in case of 8254, 1, 1 you can give, and that is known as readback command. Now, what is readback command? You can simultaneously have the value of multiple counters. Means when multiple counters are working together, simultaneously you can have the count values together. Okay, that is achieved when you will give a value of 1, 1 in this SC1 and SC0 field. Okay, so these are the meaning of or the function of these two first fields. Okay, then next two are RW1 and RW0, this read write. So the combination of these two also generate some function, like if you make it 0, 0, you see this table, 0, 0 means then it will called as counter latch command. Now what is counter latch command? So whenever a counter is working, at that instant, if you want to latch a value at a particular moment, that you can do it by selecting it as 0, 0. Okay. What is latch? You know, the storage of that value. Okay. Latch means you are storing that value. So, you know, you can use some holding registers to store the current value at that current instant. Okay. From the counter. So suppose, for example, counter is doing some count of 1, 2, 3, 3. This is the current value of the counter. Now, if you do not have the latch type of thing, then what will happen? Suppose now you need to uh, store this particular value while counter is going on. Now, when you will read this LSB2 bit, at that time there is a chance that MSB bit is getting changed. Okay, because counter will move very fast. So in order to tackle that problem, if I select counter latch command, what will happen? It is similar to just taking a snapshot of this particular thing. So whatever the at current instant, what value it comes, I will save that value in some holding register, and while counter will keep on changing the value. Okay, but at that instant, what was the value was there that I'm holding in some register. Okay, so in order to do such kind of operation, I can use this counter latch command. Then second one is 0, 1. Next combination is 0, 1. So if I take 0, 1, then read write will happen for the least significant byte. Least significant byte, what does it mean? Because I told each of the counter is of 16 bit. 16 bit means it is having 2 bytes, this lower byte and this upper higher byte. Okay, so you can do the read write operation in the least significant byte or lower byte. Okay, when you are selecting 0, 1. Now, what is the case for 1, 0? 1, 0 means you are selecting the higher byte for the read write operation. Okay, then 1, 1. So 1, 1 means first you will read or write the least significant byte, means right side you will read or write first, then followed by the left side of the 16-bit value. Okay, then the most significant byte. Okay, so in that case, you need to select 1, 1. And you know, whenever we'll be doing some counter related assembly language code for this 8254 interfacing, we have to select this mode only. Okay. you have to select both the bytes. So first of all, we have to do the selection of the first right hand side byte and followed by left hand side byte. Okay. Now, the next three fields, M2, M1 and M0. So these are the most important fields here. They will be deciding one of the modes of 8254. So 8254 has 6 different modes, mode 0, mode 1, mode 2, mode 3, mode 4 and mode 5. Out of these 6 mode, one of the mode will be getting selected by selecting a proper value of M2, M1 and M0. So 000 means mode 0, 001 means mode 1, don't care 10 is mode 2, don't care 11 mode 3, 100 mode 4, 101 mode 5. So suppose if mode 2 you need to select, so without writing don't care, if you want you can use 011 also, or for mode 3 also you can write 011. Okay, sorry, for mode 2 010 and for mode 3 011 you can write when you have to select those particular modes. Now the last field is BCD. Now if you are selecting it 0, then it will be working as a binary counter of 16 bit. Binary counter, all of you know, 00000 and then 000, and for the next count the incrementation will be 1 and 3, 2 and 3 and so on. This is for up counter, but let me tell you these 8254 counters work in a down counter manner. Okay. Now the same thing can be used as a BCD counter also, where the count values can be of like 5, 4, 3, 2, 1. That type of thing also you can do. These are the BCD count. Okay. So binary coded decimal number system also you can use to do the count operation. At that time you need to select the BCD value as 1 or last field as 1. Okay. If you select 0, then it will be working as a binary counter. If you select it as 1, then it will be working as a BCD counter. Okay. Now we shall discuss about the different mode in detail. Now the other name of this mode I have given here in this slide. 000, this mode 0. The other name of mode 0 is known as interrupt on terminal count. Mode 1, hardware retriggerable one shot. Mode 2, rate generator. Mode 3, square wave generator. Mode 4, software trigger strobe. Mode 5, hardware trigger strobe. Now each of these term has a specific meaning. The detail I shall discuss in the next slide. Okay. And the second one is also sometimes known as monostable. Monostable multi-vibrator. Monostable multi-vibrator. This is a very common term for the EC student. Okay. They have monostable multi-vibrator in their analog codes. Now, let's talk about each of the mode in detail. Now, first we shall talk about mode 1. So which is known as, also known as hardware. Sorry, first we'll discuss about mode 0, which is known as interrupt on terminal count. Now, first of all, what is the meaning of terminal count? So a counter in 8054 counts the countdown from the value you loaded in it. So whatever the value you have loaded into the counter, it will do the count in a decrement way or in down counter fashion. When it reaches to 0, suppose for example, you have given a count of 4. So what it will do? 3, 2, 1, 0. These are the 4 counts. Okay, in a down counter fashion. Now when it will reach to 0, this particular thing is known as, that event is known as terminal count. Okay. Now at that time when you have reached to 0, means you have counted all these 4 counts, your count operation is over. One interrupt is generated. Okay. When you have reached to 0, means you have completed all these 4 counts for this particular example, and at that instant if some interrupt is getting generated, then this is known as interrupt on terminal count. And in this case one interrupt is generated actually, that's why the name is given as interrupt on terminal count. Okay, so this is the simplest mode of 8254. Whatever the value you want to load, means whatever the count you want to do, that you count, n count, you give it to the load it to the counter. The counter will decrement it in every clock pulses. The output pin, you know, in counter, each of the counter of 8254 has 3 lines. One line is clock, the other line is gate terminal. These are the input, and from there you will get the output. So what type of signal you want to get, that will get from the output terminal. Okay, OUT, this is known as OUT terminal. Okay, 2 input and 1 output. For each of the 3 counters of 8254, you have these 3 lines. Clock and gate, which are the input, and OUT is the output. Okay, so OUT pin, output pin, will be low as long as the counter is counting. Okay, in this mode 0. Okay, and when the counter reaches to 0, the out will go to high state and it will stay in high. Now, what does it mean? It means, for example, suppose I have loaded a value of n equal to 4, means I need to do a count of 4. So what it will do for every clock. For example, it is working for falling edge. Okay, falling edge of the clock. So, you know, counter how it works. With every clock, the count values are getting updated. So when you have loaded a value of n equal to 4, at that instant only, the output terminal will give a value of low in mode 0. Okay. So when you have loaded this value, it is giving a this thing low output from the out terminal. Okay. So it means, for example, this 3, this is 2, this 1, and sorry. So I'm starting from here means, for example, okay, up to this much, this high, and for the first time I got my clock. So this is for 3, 3, 2, 1, 0. So these are my 4 counts, 3, 2, 1, 0. So in this interval, the value of the out will be low. Now, when it has reached to 0, after that immediately its value will become high and it will remain high until a new value is getting loaded. So this is some sort of step signal, what you are going to get from the output terminal. Okay. So this is the type of signal you are going to get. Okay. So this is the property of mode 0. So if you load some value, that at that instant your output terminal, this out will give a signal of low, and then it will remain low until you complete all these counts, whatever you have assigned to the counter. And when it has reached to 0, the last count value, after that immediately its value will become high and it will remain high until you load a new value. Okay. So this is the property of mode 0. Now let's talk about mode 1. And one more thing, when it has changed from 0 to 1, this signal, then one interrupt is getting generated. That's why the name is given as interrupt on terminal ground. Okay. Now let's talk about the next one, mode 1. So the other name of mode 1 is known as hardware retriggerable one shot. So why it is known as triggerable? A trigger signal, that is, you have to give one signal to the gate terminal to start the counting operation. Okay, that is the first property of this or first feature of this particular mode. Then output pin will go low when it will go low during the counting interval. Okay, so when you have started the operation, suppose for example, your count will equal to n equal to 4. So you want to do count of 4. So what will happen? In this case, the output terminal will generate this type of signal. The output terminal of any counter will generate this type of signal. Any terminal means which counter you have selected. Uh, for that counter, the output terminal will generate this type of signal. What type of signal? So when you have loaded this value to the counter n equal to 4, that time the value of the output terminal is high. Now, when the count operation is going on at that instant, its value will be low. Means, for example, 3, 2, 1, 0. So, as you have assigned 4 values, n equal to 4, so the count values are 3, 2, 1, 0. So, in this duration, the output will be low. For this 3, 2, 1, 0 duration, the output will be low. And when it completes this 0, after that again it will be high. Okay, so this is the property of mode 1. Okay, in mode 1, this type of signal will be generated by the out terminal, this type of signal. What I told, initially when you have loaded n equal to 4, that time its output will be high, and after every clock, when you have started the count operation after every clock, how to start the count operation? Other than that, a clock, you should have a proper signal in the gate input. So you have to give a proper signal to the gate input, then only the count will start. Means you can have a count of 3, then 2, then 1, then 0. So 4 count. So after this 4 count, again your output value will become high, and it will remain high until you give a new until you load a new value to the counter. This is the property of mode 1. So why this is known as hardware retriggerable? So first of all, hardware triggerable. Hardware triggerable means as gate terminal is used to start the counting operation. That's why it is known as hardware. Triggerable means trigger is applied to the gate terminal. Now what is the meaning of retriggerable? Retriggerable is, suppose for example, you have activated the gate terminal in the first counting. So when it has come to 3, okay. So what it will do? 3, 2, 1, 0. We know this is a very common thing. Now after counting 3, again you have given a trigger in the gate terminal. What will happen? Again it will start from 3 and continue the process. So what I'm trying to say, if in the initial stage, if you give the clock or gate, if you give a proper signal in the gate, it will do this count like this way. Now after completing the 3 count, again if you have given the, after finishing its 4 count value, still if you are applying again one gate trigger, what will happen? It will start the counting again from that instant. So for example, it has already completed a count of 3, then it should come to, it has already counted the value of 3, now it has to come to 2. But meanwhile, you have again given one trigger in this instant, at the third instant, in this position. So what will happen? Again, it will start from 3. Again, it will start from 3. So what will happen? 3, then 2, then 1, then 0, and then it will be high. Okay. So this will be the shape of the signal. First it was 0. Let me draw it by another color. Initially it was 0. Here it was 3. Then you have given the trigger once again at that point. Again it is starting from 3, then 2, then 1, then 0, and again high. Okay. So that's why this is known as retriggerable. In between means before completion of the uh, count, if you again trigger the gate terminal, it will start the count from the beginning itself. Okay, that's why this is known as retriggerable one shot. Hardware retriggerable one shot. So if another trigger arrives while counting, the timer is retriggered. So restart the counting from the beginning. So this is the property of mode 1. Now let's talk about mode 2. Mode 2 is known as rate generator. Rate generator means particular periodic pulse will be getting generated at a fixed rate. And this is also known as programmable frequency divider. Okay. What programmable frequency divider? Whatever the clock frequency you are applying to the counter, that clock frequency, from that clock frequency, you can generate a new clock frequency by using this type of counter in mode 2. Okay. For example, you have assigned a clock value, you are assigning a count value of n equal to 4, and the frequency of the clock signal is f. Now, if this clock is applied to this particular counter in mode 2, then the signal what you are getting from the output terminal of the counter, its frequency will be f by 4. So that's why this is known as programmable frequency divider. What frequency divider? You have a frequency of the clock signal that is getting divided by the number of count you are assigning to the counter. And this is the updated frequency what you are going to get from the output terminal of the particular counter what you have selected. It can be counter 0, it can be counter 1 or counter 2. Okay. So how it generates the signal? Load the count value. Suppose you are giving n equal to 4. So out will means out terminal will have a high value in the beginning. Okay. Output terminal will have a high value in the beginning. For example, you have given n equal to 4. So it will have a high value. This is you have loaded. Then what will happen? 3, 2, 1, 0. These are the count values 3, 2, 1, 0. And in this duration, it will remain high as it is. Okay. And when it will low, so it will low in the last pulse. It will be low in the last pulse. Last pulse means when you will reach to 0 state, at that time it will be low. So what I am trying to say, the signal will be this shape. So it is when you have loaded n equal to 4, that time also it is high, then it is having the count 3, 2, 1. And when it will reach to 0, at that time it will have a low value for the last clock, or for the last, for the last clock. Because you have to get 4 counts, 3, 2, 1, 0. Okay. So for the last duration, it will be having a low value. Otherwise, in the remaining case, it is having high. Now, when it will complete the last count, that is 0 value, again it will automatically get a high value. Okay. So you no need to keep on loading the 4 value again and again. It is automatically repeated. So when you have loaded n equal to 4, after completing this operation, again that value is getting loaded. So next time again it is 3, then 2, then 1, and then 0 again. Okay. So this will be the shape of this signal. Again, I am drawing here. The shape will be this one. Then low, then high, then low. So it remains high for 3 consecutive cycle, and for 1 cycle it remains low. Then again 3 high for 3 consecutive cycle, and for low for 1 cycle. So this is the shape for this particular example of n equal to 4. Now, if I want to measure the frequency of this signal, then it will be nothing but the frequency of the clock signal divided by n equal to 4. Means f by 4. This will be the frequency of this new signal, which I am getting from the output terminal of the selected counter. So that's why this is known as rate generator. This signal is generated at a particular rate, that is f by 4. Now the next mode is mode 3. The other name of mode 3 is known as square wave generator. So in this case, whatever the count you want to give, that you apply to the counter, and what it will do, for example, we shall take one example. For example, n equal to 4 I am taking again. So what it will do, so you have loaded n equal to 4 value. So at that time it will be high. And when it starts the counting operation, means when the value is becoming n equal to 3, it will be high. Then it will be low for 2 and 1, and again high for 0. This will be the shape of square wave generator. So this is high for 3, then low for 2 and 1, and high for again 0. Then same thing will be again getting repeated, means that again you have 3, then 2, 1, and then 0, and so on. So in this case also, you no need to keep on loading the value n equal to 4. Automatically it is getting a repeated value, and this type of shape will be continuously generated. Okay. So for the first clock, or actually first time it will be high, and then it will be low, and then this operation will be continuously happening. So it means if you have n equal to 4 for even signal, or for even number of this thing count, it will have n by 2 number duration high value, n by 2 number duration low value. So this is n by 2 low value, n by 2 high value, because if n equal to 4, for 2 count it is low, for 2 count it is high, and so on. Okay, this is the property of square wave generator. Okay, now if n equal to 5, what will happen? If n equal to 5 means if you give a odd value, what will happen? So it will be high for n plus 1 divided by 2 clocks. So that is 5 plus 1 divided by 2, that is 3 clock. And it will be low for n minus 1. N minus 1 means for this particular example, 5 minus 1 divided by 2, that is 2. Okay. So it will be high for 3 cycle and low for 2 cycle. Okay. If the value of n is odd, or n equal to 5 if you consider. Okay, and this is the property of square wave generator, and generally we'll be using the even value only to get a square wave, means on time and off time will be remaining same. and you no need to keep on repeating or loading the same value. Automatically it repeats its value. So automatically the signal will be getting generated again and again. If you load one time this n equal to 4 value count, for example. Okay. The next one, mode 4. The other name of mode 4 is known as software trigger strobe. Now what is strobe? Strobe is some sort of single pulse. Okay, strobe is known as a single pulse. So what is software trigger strobe? Software trigger strobe means triggering will be done through software, not by using gate terminal. Okay. So when you will load a count value, automatically a triggering operation will be done and count will be getting started. That's why the name is given as software trigger strobe. So what will happen in this case? For example, you give a load value of n equal to 4, means you are giving a count value of n equal to 4. At that time, out for that particular counter, out will generate this type of signal. What type of signal? This will be, so when you have loaded n equal to 4, that time the output is high. For 3 also it is high. 2 also it is high. Then 1 also it is high. And when it will come to the last one, when it will come to the last count, at that time only it will be low. Okay. So 3, 2, 1, 0. This will be the shape of the signal. Okay. So this is the shape of the signal, but it is not getting repeated. Here it will stop and it will remain high once again. After the 0 count, again it will be high. So the shape of the signal is initially when you have given n equal to 4 this particular count, the out will generate a high value, and when you have the last count, that is 0 value count, it will be low and it will remain low for the last count, and again automatically it will become high and it will remain high. And this is not automatically getting repeated. You have to give a new value or some other value or same value, then only it will start processing or it will start making the next part of the signal. Okay. So why the name is given as software? Because you have to load the value and automatically it is giving triggered, not by using hardware. Now mode 5 is known as hardware trigger strobe. The principle what I followed for the previous case, same type of wave will be generated like this way. However, in this case, why it is known as hardware? Because you have to give trigger in the gate terminal, then only counter will start counting. In the previous case, counting was started by only loading the value and software itself it was generating the trigger. However, in this case, you have to give the gate signal to start the counting or to trigger it, and same type of signal will be generated what I discussed in the previous case. It means for n minus 1 number of cycle it will be remain high, and at the last cycle, for the last cycle it will remain low, and again it will come back to high. This is the property of mode 5. So hopefully all of you have understood the content